Hello everyone, welcome back to the course Vector Calculus and Complex Analysis. Myself Dr. N.CH.Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. Today, I am going to continue the last session. In the last session, we have discussed about a bilinear transformation from the given set of points in W plane and Z plane. We can find the bilinear transformation. So today also I am going to continue the same topic to solve some problems on bilinear transformation. Now what is a bilinear transformation? Any transformation of the form W equal to AZ plus B by CZ plus D, where A, B, C, D are complex constants and AD minus BC is not equal to 0, is called a bilinear transformation. And a bilinear transformation preserves cross ratio property. What is the cross ratio property? Cross ratio property. If there are 4 points T1, T2, T3, T4, then the ratio of T1 minus T2 into T3 minus T4 divided by T1 minus T4 into T3 minus T2. Simply we replace or we interchange T2 and T4 in the denominator. So we follow the order 1, 2, 3, 4 in the numerator and in the denominator 1, 4, 3, 2. So this ratio is called cross ratio. And if there are 4 points given in Z plane and W plane, 4 more points, then the cross ratio of these 2 points is the same. So using that property, we can find the bilinear transformation from the given set of points. Coming to the first problem, find the bilinear transformation which maps the points Z equal to 1, I minus 1 onto the points W equal to 0, 1, infinity. So here 3 points for Z and 3 for W given. But to find the cross ratio, we need 4 points for each. So I'll consider the values of Z as 1, I minus 1 and the 4th point as Z. And for W, 0, 1, infinity and 4th one as W. Now using the cross ratio property, so just now we discussed 1, 2, 3, 4 and 1, 4, 3, 2. So 1 minus I minus 1 minus Z divided by 1 minus Z minus 1 minus I, which is equal to 0 minus 1 infinity minus W by 0 minus W infinite minus 1. Now we need to simplify this to get the final bilinear transformation. So here there is one more important point. If any ratio is involving that infinity term, then that ratio, we consider that ratio is equal to unity 1. So here infinity minus W by infinity minus 1, this becomes 1. So here by taking minus common, 1 plus Z into 1 minus I by, here also we can take negative common in denominator. So minus 1 minus Z into 1 plus I, and here which is minus 1 by minus W, since the ratio infinite minus W by infinite minus 1 is equal to 1. So we consider any ratio having infinity is equal to 1. Now here these two gets cancelled. So 1 by W equal to 1 plus Z by 1 minus Z into 1 minus I by 1 plus I. So this is equal to 1 by W equal to, now let us multiply and divide the numerator and denominator with this 1 plus I. So 1 minus I into 1 plus I by 1 plus I whole square. So which is 1 plus Z by 1 minus Z into 1 minus I square by, here A plus B whole square, 1 plus I square plus 2I. So that implies 1 by W equal to 1 plus Z by 1 minus Z, and here minus I square. I square is minus 1. So minus of minus plus 1. So 1 plus 1, 2. 2 divided by, and I square is minus 1. So these 2 gets cancelled and 2i remains by 2i. So these 2 gets cancelled, and that implies 1 by w equal to 1 plus z by I into 1 minus z. And we want w in terms of z, w equal to I into 1 minus z by 1 plus z. So this is the final or required bilinear transformation of the given points. So if 3 points are given, we consider the fourth one as z and w respectively for a z plane and w plane. And then sometimes, if necessary, we apply a componendo and dividendo rule to simplify the ratio. And finally, we can obtain the bilinear transformation. Now coming to the second problem, here under the transformation w equal to 1 by z, find the image of the circle. So a circle in z plane is given. Now using this transformation, how the circle will be transformed to the w plane. So here given circle is mod z minus 2i is equal to 2 and w is 1 by z. So we know that what is w? U plus iv is 1 by x plus iy. So that implies u plus iv equal to, now again multiplying on both sides, multiplying the numerator and denominator with x minus iy. Here we get x square minus I square y square. So u plus iv equal to x minus iy by x square. I square is minus 1. So here we get plus y square. So that implies u plus iv is equal to x by x square plus y square minus I into or plus I into minus y by x square plus y square. So comparing the real and imaginary parts on both sides, we get u is x by x square plus y square and v is minus y by x square plus y square. Now for example, if we want to find u square plus v square value, squaring on both sides. So this is x square by x square plus y square whole square plus y square by x square plus y square whole square. So u square plus v square is x square plus y square. So here we can take x square plus y square, taking the LCM whole square. So u square plus v square is 1 by x square plus y square. Using this final transformation here, we can consider x, just we can replace x and u and v by x and y also. So u by u square plus v square and y is v by u square plus v square. So these two transformations we have. Now what is the given circle? Given circle mod z minus 2i is equal to 2. So that implies what is z? X plus iy minus 2i equal to 2. So here x plus I common, y minus 2 is equal to 2. So by finding this magnitude, here we get x square plus y minus 2 whole square under root is equal to 2, so which is equal to 4, squaring on both sides. So x square plus y square minus 4y plus 4 is 4. That implies x square plus y square minus 4y equal to 0. These two gets cancelled. Now we can use these two expressions for x and y. So u square by u square plus v square plus v square by u square plus v square minus 4v. So v is again with minus sign. So this becomes plus v by u square plus v square is 0. So here this becomes u square plus v square by u square plus v square plus 4v by u square plus v square is 0. So this is 1. So 1 plus 4v by u square plus v square is 0. So x square y square, here we have whole square term, whole square. So this square gets cancelled. So u square plus v square. So which is 1 plus 4v equal to 0. So that implies 4v is minus 1 and v equal to minus 1 by 4. So which is again a straight line in W plane. So here a straight line, a circle in Z plane is transformed to a straight line in W plane. Coming to the third problem, show that the transformation, again the same, W equal to 1 by Z, maps a circle to a circle or a straight line if the former goes through the origin. So either it transforms into a circle or a straight line. Just now we have proved that in the previous problem a circle is transformed into straight line. Similarly here sometimes it may transform into a circle also. So that we need to prove. So again the same, u plus iv is 1 by x plus iy. So which is u plus iv is 1 by or x minus iy by x square plus y square. So x equal to, I can take u by u square plus v square and y equal to v by u square plus v square. Similarly here you can interchange these two and simplify, you will get the same. For example, if I write x plus iy equal to 1 by u plus iv and then simplifying, we will get the same things here with minus. Y term is having negative sign, here we have minus. And now what is the general form of a circle in Z plane is a into x square plus y square plus bx plus cy plus d equal to 0. And we have the expressions for x and y. So substitute these two here, a into x square u square by u square plus v square whole square, y square v square by u square plus v square whole square plus b into x u by u square plus v square plus c into minus v by u square plus v square plus d equal to 0. So which is, by taking LCM here, a into u square plus v square by, so 1 by u square plus v square, those two terms gets cancelled, plus b into u by u square plus v square minus c into v by u square plus v square plus d equal to 0. And again simplifying, we can have the LCM here and d is a constant term. So we can start with that, d into x square plus y, u square plus v square. So d into this u square plus v square, then plus bu minus cv plus a equal to 0. So which is again in the general form of, most general form of a circle. So which is a circle in W plane. So a circle in Z plane can be transformed to either a straight line or again a circle in W plane. So in today's session, we have obtained the bilinear transformation of the given set of points. So that means a transformation in the form of az plus b by cz plus d. And also if a particular figure in Z plane is given, we can find after transformation how the shape of the figure will be. Either the same shape, it may continue the same shape, or else it may transform into some other. For example, we have discussed an example in that a circle is transformed to again a circle or a straight line in W plane, under some transformation W equal to 1 by Z. So this is for today's session, and we'll meet in the next session. Thank you.